everybody, here we are for CC Rainbow Monday's science experiment. This is for week number 16. This is our science experiment number 93, Bubbler. And this one has to do with the reaction between baking soda and vinegar. Here's the components that we need for this particular experiment. We're going to need vinegar. We're going to need some soap. We're going to need some baking soda. We're going to need toilet paper. We're going to need some straws. I got two different types of straws that you can use. This one's a little bit thinner walled straw, and these black ones are a little bit more rigid, thicker walled straws. We've got a pair of scissors. We've got a funnel. We have a syringe here and an extra cup. We're going to put our soap solution inside of here. I've got some baking soda over here ready for us in this bowl. We got a magnifying glass so your kids can kind of look at what's going on. We have our bottle, and I have our modeling clay as well, and then we have some paper towels. So a lot of stuff going on here. What we're essentially going to do is we're going to take the straw, and we're going to put it inside of the bottle with some modeling clay around the edge, so we're creating an airtight seal, and then we're going to have the baking soda and vinegar reaction happening inside, and then we're going to take some soap and put soap on top of the straw, and then the carbon dioxide that is released from the reaction between the baking soda and the vinegar is going to create little bubbles on top of our straw when we have put our soap mixture on top of our straw. So that's what we're doing here. Let me go ahead and explain what's happening with vinegar and baking soda. Now, vinegar is an acid. It's acetic acid. It's actually a diluted acetic acid. And your baking soda is sodium bicarbonate. It is a base. So vinegar is an acid, and baking soda is a base. Now, the difference between bases and acids, an easy way to remember them, is bases are wanting to give up their electrons, and acids are wanting to take electrons from somewhere else or something else. So you can think of bases as being, say, like you can explain it to the kids that the baking soda is a base. It's like a giving person, someone that's just always giving to other people. Oh, here, you can have this, you can have this, you can have this. Whereas vinegar, the acid, is always wanting to take. It's always, oh, I want this, I want that, I want this, I want that. And so what's happening on the molecular level is the vinegar is breaking apart the baking soda, because the baking soda is wanting to give out its electrons. So it's actually the vinegar is going, oh, I'll take everything you've got, and it actually breaks it apart down to its different elements and chemical compositions. And what happens is the carbon dioxide is released from the baking soda. Now, baking soda's chemical composition is Na, which is sodium, HCO3. So if you look at that, we have an H, which is hydrogen, and CO3. So we actually have a CO2 molecule in there, and we have an extra oxygen molecule. So when these two combine, you have hydrogen is, like I said, the dilute acetic acid. It's HCH3COO, which is an acetate ion with an extra hydrogen on it. So when they go and they mix together, when we're mixing together and you're seeing it all kind of bubbling and fizzing and stuff, what's happening on the molecular level is there is the extra hydrogen within the vinegar. So you have a hydrogen, and then you have the acetate ion, the big long mixture after that. That hydrogen is actually going and it's combining with the individual hydrogen and oxygen on the the baking soda, because it has NaHCO3. So there's an H in there, the hydrogen, and the O3, there's an extra oxygen. So the extra hydrogen is combining with the extra oxygen and hydrogen in the baking soda. What does that make? Two hydrogens and an oxygen is water. So you have H2O now. So hydrogen and oxygen. So we're making water in the bottom of the bottle, and then you have the acetate is actually mixing with the sodium. The sodium, when it's sodium acetate is what you're making, which is a type of a salt. If you actually look at the chemical composition of salt, salt is NaCl, which is sodium and chlorine. And so you're making a sodium acetate. You're making a type of a salt inside of your bottle. So you're taking those two, and then once you've taken the sodium and the hydrogen and the extra oxygen away from the baking soda, all that's left is carbon dioxide, that CO2 molecule that's in there. And that CO2 molecule is what is rising up inside of the bottle, and that's what's going to go into our straw and come out, and we're going to capture it inside of a bubble, and that's why we're able to make a little bubbler. So that's what's happening on the molecular level. Because acids always want to take electrons, and bases are always willing to give electrons. So the base is giving its sodium electrons as well as its hydrogen electrons and its oxygen electrons. It's allowing them to be shared with the extra hydrogen and the acetate ions within the acetic acid solution of the vinegar. Now let's move on to the experiment. So let's go ahead and get our bottle. We got a few things that we got to kind of set up a little bit here. We're going to take our vinegar and grab our funnel, and we'll go ahead and put in. My lid is a little bit off right here. We'll go ahead and we'll put in, we'll say about that much down at the bottom of the bottle. Have that in the bottle, just kind of about that much. It's not really, you don't have to be super exact. I'm going to go ahead and set these guys aside here, and we're going to prep our straw. We're going to take our straw and we're going to put it about halfway. So I want to take some of my modeling clay, and we'll just grab one of these pieces of modeling clay, and we'll just use half of it. There we go, half. And what we'll do is we'll wrap it kind of around the outside edge. We may need to roll it or something. Let me see here. Around the outside edge, because what we're wanting to do is get it to the point where it can be a little stopper. I may need more. Actually, let me get the whole piece of the modeling clay. Stuff actually seems a little dry. Maybe that's why I'm having problems. We want to create
airtight.
Yeah, an airtight seal. Sorry. Just kind of see if we can get it to go. I think it just doesn't like the plastic of the straw. There we go. So it's going to look something like that when it's on there. Now, let's go ahead and take a small piece of a paper towel. I'm going to take about the size of a 3x5 card out of my paper towel, and we'll go ahead and we'll put in about a teaspoon, well, this is a tablespoon, either or, both end, full, and then I'm going to kind of roll it up inside of here. And what we want to do, I may have too much, I don't know if I can fit it down the neck of the bottle. We got to make sure that we can fit it down the neck of the bottle. And then we'll just kind of twist off the ends here. I have a couple of
Can I get closer?
Chunks. Yeah, go ahead and come on over. You can take a look. We're just going to kind of make like a little packet. A little food packet. Baking soda is going to be giving today. Okay. All right. Okay, go ahead and back the camera up. So our packet is ready. Our straw is ready. Our vinegar is ready. So we need to make our soap solution. So we're just going to take, in here they say do 2 drops of soap and 2 drops of water. So we definitely don't want to use too much, but I like, what is the deal with my deal here? I like putting it out in.
You should probably take the lid off.
Yeah, looks like it's a little dried or something. We'll just do a big
Flop.
big blop. There we go. Dawn dish soap works extra good, but
We have that.
any soap will actually work just fine. It's not, you don't have to be picky about it. And then we'll just put some water in there, and we'll kind of stir it around. Decently thick solution. I may have put in too much water. It's not that big of a deal. But what you probably will want to do is just try it out. Put your finger in there and see if you can get a film. There we go. I got a film on my thing, on my straw, and I'll just blow in it. Oop, too thin. A little, maybe I'm blowing too hard. There we go. All right, working. Wonderful. Now, here's what we're going to do. We're going to drop our baking soda packet down inside of here. We've got a couple of seconds before the reaction starts, before it gets through the paper towel, before it makes it through the paper towel. It works really good if you have a thinner paper towel or toilet paper. Actually, I was supposed to do it with toilet paper.
I was waiting for you to make that connection, but
Let's try this again. Back up the tape.
those Viva paper towels are really thick.
Yeah, these are really thick. I usually do it with a thinner paper towel, so this is fine. Make fun of me. Let's see. All right, here we go. Now we'll roll this up. Yeah. Now we're talking. Just use like 2 squares of a piece of toilet paper. Will work great, and it will twist easier. There we go. We have created our deal. So now we're going to try and get this down in here. Have your straw ready. It's going to start releasing. You can kind of see some bubbling happening down there. Let's get our bubble up on top. Whoa, look at that. It's already blowing bubbles, people. Blowing bubbles. So we can kind of give it a little bit of a shake, and it'll slowly release some more hydrogen and carbon dioxide. Let's get another little bubble. You will have to keep making bubbles. You can hear it. Hear the bubbling? And that's when you can have your kids kind of come and look at the... You will have to keep putting... It's actually coming out fairly quickly. Whoa! Coming out so fast I can't even get the bubble on there. You guys see that? Come on. It's really coming out. Ain't no way we making bubbles now. We're making bubbles down here. I don't know, let's just put some more soap solution down there. There we go. Slowing down the reaction a little bit. Pretty cool.
That's awesome.
And there's our little bubbler. Now, if you want to, you could try this all over again. You could try different lengths of straws. You could do a shorter straw. And you could do a longer straw. You could actually try to see if there would be a difference with having it closer down to the bottom if you're going to make bubbles faster or slower. Because the carbon dioxide is rising. I don't know. I haven't tested it myself. Since the carbon dioxide is rising, it's possible it could come up here and be pressurized and not be able to get into the straw. So it could slow the reaction to have it further down, or it could speed up the reaction to have it further down. It could go both ways. Get a little bit more on there. And another, you could do almost the same exact thing with a balloon, if you had a balloon. But what I would do is I would take some time and explain to the kids what's happening down there. And when you look at the liquid, you'll see it's constantly bubbling. It's constantly, the baking soda is constantly giving. He goes, here's more, here's more. And you can tell the kids it's kind of, baking soda is kind of like a party person. They go in and they're giving away presents, and then at the end of the party, the balloons are released, and that's kind of what the carbon dioxide is. The carbon dioxide is floating up into the air, and the vinegar is all the selfish little children at the party that are going, give me, give me, give me, give me. So anyhow, have fun with that one. That's that. And that was fun. Now it's time to go.
Your analogy.